this is one of the more challenging problems I can give you. So measure of angle P is 30, and this is a tangent, so that's going to cross at a right angle. We have to remember that from first semester. So that's a right angle, we have a right triangle, which means this must be 60. And now we've got a 30, 60, 90 right triangle. QM is the radius. QM is 12. We're going to need that. So what's going on here? We need to do the area of this shaded little weird thing. So we have to notice that this part is a sector, and we know how to find the area of a sector. So if we found the area of the entire triangle, this MPT, minus the area of the sector, that would give us this kind of weird little sliver that doesn't really have a name, this kind of like triangle looking thing. So that's what we need to do. Area of the triangle, which is base times height divided by 2, minus area of the sector, which is whatever that central angle is divided by 360 times pi r squared, because that's the area of the entire circle, and this ratio gives us the slice of that circle, like what percentage that sector is. So let's do the triangle first. Base times height divided by 2. Well, we don't know any of the sides of this triangle, but we do know the radius is 12. That's all we know. So this is 12. Okay, so then actually what this means is this is also the radius, which is 12. If I connect that to that, it's going from the center to the side. It has to be also 12, and it's across from a 30-degree angle, which is the smallest side, so makes sense. The hypotenuse, which is this entire thing, would have to be double 12. So now I know this side is also 12, because this entire hypotenuse has to be 24. And now this last side of the triangle would be 12 root 3 coming from our 30, 60, 90 right triangle. Or if you forget that triangle relationship and you figure out this is 12 and this is 24, you could just call this A, and do A squared plus B squared equals C squared, and get the value of A using Pythagoras. So now we can find the base. Let's just say that's 12. And then the height of this triangle would be 12 root 3 divided by 2. Okay, we can figure out what that number is on the calculator, beast. 12 times 12 root 3, enter, and then divide by 2. 124.7. I'm just going to write 124.7. We do not want to round that yet. I'm just going to keep that in my calculator. Now let's go to the x over 360, so our central angle is 60, which is exactly 1/6, times pi times the radius squared. So that's going to be 1/6 times 144 times pi. It's okay if I kind of rearrange this. Doesn't really matter. Let's just do that apart on our calculator. 144 times 1/6 is the same thing as divided by 6. And then times pi. 24 pi. I'm actually just going to write 24 pi here because it's going to be an easier calculation. 124.7 minus 24 pi. I can actually go up here. Oh, I can't on this calculator. If I do 124.7, I'm going to write in a couple more decimals just to be a bit more accurate, and then do minus 24 pi. Okay, so now I'm going to round that to the nearest tenth. 49.3. Let's just see what would have happened if I would have just done 124.7 minus 24 pi. I would have gotten the same thing to the nearest tenth, but notice the other decimals are changing. So if you're just rounding to one decimal place, it's not a big deal to keep all these decimals, but it is, this pi right here symbol that I used has 8 decimal places within it. So I would use this pi symbol as much as possible instead of 3.14. Okay, so that's it for this problem.